Okay, so we want to find the volume of this torus, and so the torus is formed by, this particular one, is formed by rotating a circle. Let me just kind of outline the circle here. Sort of outline it. So the idea is that this is a circle of radius b. And so the equation of this circle is x minus a squared plus y squared equals to b squared. So here the center from the, let's assume this is the axis. So this is 0, and this point would be A. So this circle of radius B is rotated around the y-axis. So if you rotate it around the y-axis, you form this shape that we see right here. It's called a torus. Okay, and we want to find the volume of that. So interestingly enough, we're going to use this circle here, but we're not going to use it in the way that you're thinking. What we're going to do is, let me show you it's sliced. So here we've got, this is a, sorry, okay, half torus, and so the circle right here is, so it's right here. Let me just kind of outline it. And so this is the point, this is the axis, this is 0, this is A, and right here this is A plus B. What we're going to do is, instead of looking at it as using this circle, if you take a look, at this cross section, this is basically a washer. And so let me draw the washer right here. So this is our washer. And so that's the washer. So let me kind of draw it right here. And basically we're going to take the area of this washer, and so then we're going to integrate from the bottom over here to the top. So from the bottom here to the top of the torus. So then our task is to find the area of the cross section, which is what I drew right here. And so essentially this point on my washer is, let's just kind of assume that this cross section, this washer, is located right here. And so what I'm looking for then, oh, that's not a good color, let me use this one. Okay, so then what I'm looking for is the distance from here all the way to here. Well, this point right here and this point right here are both points on that circle right there. And so this is simply, if I solve for x here, I would get a plus or minus the square root of b squared minus y squared. And so that makes sense. I mean, this is a right here, and then you're just going to either add this much or subtract that much to get your 2 points. And so this guy right here, this is a minus the square root of b squared minus y squared. And this point right there, that's a plus the square root of b squared minus y squared. And notice that we're going to integrate from, this is negative b to positive b. And so then my integral is going to look like the integral of pi. It's going to go from negative b to b, and then it's going to be the big radius squared, which is a plus the square root of b squared minus y squared, so pi r squared, so the radius from negative b to b, minus the small radius, which is a minus the square root of b squared minus y squared, squared. And all of this is going to be with respect to y. Remember, a and b are constant. Okay, so if you simplify this a little bit, what you're going to get is this is the same as 4a pi, the integral from negative b to b, of the square root of b squared minus y squared dy. And this, you don't do this analytically, but you'll notice that this right here is the area underneath a half circle of radius b. If you were to graph that. So the volume, this is going to equal to 4a pi times 1/2 pi b squared, which is equal to 2 pi squared a b squared. And that's it.